window. This is your input, like x's on the left, and then here's the y's right here. Nothing crazy about that. It's just a little telling you in this particular window, here's a nice little function. Okay, over here is a nice little function that goes from negative 4.7 on the left to 4.7 on the right, up and down, negative 3.3 to 3.3. You can kind of see those values in there. You can measure it by the tick marks. Last one, negative 4.7 again, and then the negative 3.3 and on. That's what those numbers stand for. So, which of the three graphs shown below, which one is not a function? Do you remember like algebra 2? You totally got this. Name it. A, B, or C is not a function, and it's, you got this. You think it's A, B, or C? We have to employ the, so, well, you can guess. If you come up with it, let me know. So today, while you're working, I'm going to show you something. This is being recorded because you should see this. And I don't mean to torture you. Not that much. I mean, a little. Watch this. The random student selector. Look at this. I have a place for you. PreCalc block 2. And I'll let you chat with people. And I'll click on you and have this. Well, right now I don't have you guys loaded in here. But I will, because right now I'm working on your nicknames. So this is my third block, Calc 2. Want to see the names in there? Look at that. And this is how it works. It's subtle. It's very subtle. Not distracting at all. And then you get a chance to respond. An opportunity, let's call it, to respond. And nice, I can choose whether or not you're removed. So Nicolund, so if you guys know Nick, he gets picked. And then he's taken out of the list. Now it's the Maxter. He can take his. And then Hart. And finally, and then these guys don't get Ninjago. Okay, so those are some of the folks that you might know in my third block class. It's Calc 2. But I'll get you guys in there, I promise. And if you can help me with the nickname, I'll get to it a little bit later, but I have to enter you. I have not yet done that. So anyhow, anybody come to a conclusion, by the way, on this one, what they've got? Which one is the non-function, A, B, or C? You feeling good?
C.
Yes. C. 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 Like Spanish, yes. Yes. You're correct. Good. Yeah, it's totally C. And it's the vertical line test. So if y'all remember non-function stuff, nothing fancy, and I can, if you have a vertical line that hits more than once anywhere, like at any time on that function it hits more than once, it's not a function. So that's the deal. Non-function if vertical line, and I think that's down below. So we'll repeat this again. Vertical line hits more than once. Okay, so that's the non-function if vertical line hits greater than one time. Old school stuff, right? You've seen this before. And hey, it's right below us, vertical line test. Unbelievable. And it says, it defines a function x if and only if, I should say, that vertical line hits once. It's only a function if the vertical line touches once. Everywhere. No exceptions. None. Okay, old news. Domain of the function. Here's the deal. Domain is the possible x's that you can have for this thing. So that is our possible inputs. You can think of it both ways right now because we're going to stick to x's for a while. So possible input values. Generally speaking, if you're talking about polynomials, like nice smooth curves with no breaks in it, there is no limit on the domain. That means there's no x value you can't put in on a polynomial. So it's good to know. So we've been dealing with polynomials for years. So in the function, I'm going to write that first actually because I don't think that's on here. Polynomials, like x squared, x cubed, those kind of things, even a line, they are the domains that are all real numbers. I'm going to write it a couple ways. Okay, polynomials have domains of this little symbol. Okay, it's called, that's a double-backed R, which means all real numbers. And if I was helping my son with his homework last night in 2nd grade, he was learning appositives. And I have to tell you, I had no idea what an appositive was. But an appositive is a phrase or sentence after a noun that describes that noun. So I could have written this in such a way that that symbol, and then I described it afterward, it would be an appositive. It's your English lesson for today. So all real numbers. What that means is I don't have any limitation on what x's I can put in there on a polynomial. The other way we write that with interval notation is negative infinity to infinity. Remember that from the other day. Okay, this is the interval version notation. Okay, gotta like those. That means any x from negative infinity to infinity, not including infinity because I can't capture infinity. No way. Not until Calc 2. If the function has a fraction in it, you set the denominator equal to 0. So I'm going to give you a little bit of an example in a minute. So this is something we're going to itemize in a moment. And then the second one says, so setting the denominator equal to 0, that's a big deal if the function is a fraction. Okay, got it. We'll talk about it with an example. If the function has a root with an even index, now that sounds funny, doesn't it? So here's what an even index is. A root with an even index, my appositive would be a power of 2, 4, 6, 8, etc. So a 4th root, that's an even index. Okay, well, square root's the most famous. Okay, what I want to put in here is a reminder of what that also means in power mode. Do you remember that's to the 1/2 power? This is x to the 1/4. Okay. So even index means it's one of those with an even root of some kind. So 6th root of x, and I think you get the idea. I don't want to overdo it. Okay. So what you do for that one is you set the expression under it greater than or equal to 0 to find the domain. So that sounds odd, but I'll give you the quick dealio on that one. If I take the square root of blob,
Katie Rubel, please come to the office.
then
Katie Rubel to the office.
this is the deal. My blob, whatever's in there, you can't take the square root of a negative when we're dealing with the real numbers. So what we'll do is just make sure whatever we put into that blob, the blob is greater than or equal to 0. This means no negatives, and we should put that in some kind of bold other color. No, that's a gross color. Let's go, ooh, fluorescent green. This means only non-negatives. 0 works. There's an E at the end, but you can't see it. So only non-negatives. That's what that is. We'll itemize, we'll take care of this all in examples, but this is the going back to the beginning. Okay, if your function is a realistic model, then it may leave only positive values for the domain. That means there's like a context, like read the problem. Okay, so this is the deal. Read the problem. So if I have, for example, domain is the things you can input. If I do a model for testing performance, which is such a boring topic, but we see it all the time. Testing performance. All the Iowa schools have been graded recently. Testing performance graphs all over the place. Well, there's a domain issue. They break them up by age group or grade level. So if your X values are your grade level, okay, then not all possible X's work. We start at kindergarten. I don't know what you'd call that. Do you call it 0? Do you call it like half? Do you call it grade 1 sounds great, grade 1, grade 2, 3, and so forth. When you get into college, do you call it like 13th grade? However you want to decide this. So when it comes to dealing with real problems, oh, do we have negative grades? Is that it? Not so much. So domain also has to do with context of the problem. Like, can I put in any age I want to or any grade level? And no, the context will dictate that. Okay, so read the problem. Grade level is a limited domain. So that's what I'm going to put after this. So grade level has a limited domain. Just means you can't put everything you want. All right. And the same thing, there's a limit in the end too on the possible scores, the output. All right. If you contain any one of the 3 above, you will need to consider all cases. So we're just talking about the idea that we have, you can't see my mail message, these limitations, they're either mathematical or they're contextual. So let's play first with interval notation, and then we're going to do a whole bunch of problems, and it's going to be great. Down below, just to remind you, if you haven't done interval notation in a while, like x is greater than 5 as an interval would look like this. 5 to infinity, and you want to be careful, this is a parenthesis on the end, on the left-hand side. So parentheses are really important. Means not including. I'm not including 5. Am I including like 5.1? Yeah. 5.01? 5.0001? Anything slightly bigger than 5 works, but if I say 5, that's not actually in this interval. It's not included. X less than 0, you have to start negative infinity to 0. So intervals always go from small to big. So you never, and this will be a pretty common error. Somebody in here, one of us is going to goof that up. You're going to turn it around. Small to big is how intervals are written. You always do the small on the left, big on the right. Kind of like a number line. Small to big. Okay. Then, dun, 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 this one down here, if I have an or involved, we can mix this up a little bit. X is less than 3 or x is greater than 10. So I'm going to put in here negative infinity. I could do better with the infinity. To 3, not including 3. So the fact that all of these have no equal sign in the inequality means I'm using a lot of parentheses today, so far. Parentheses all over the place. Or is a funny symbol. It's a U symbol we put in there. It means or in union. Mathematically, a union is an or. Some other plays on words in there, but 10 to infinity. You stats people or probability probably remember dealing with that. Okay, interval notation itself is a little bit tricky. And the next one, x greater than or equal. This is different. So each one of these has a selected equal sign in there of some kind. So we're going to note that. That's important. So if I do x greater than or equal to 5, similar to what I had before, it would be 5 to infinity, or the possible x's, but this time there's a bracket on 5 because it's equal, includes. So that's the deal. That bracket includes 5. Next one down is a squeeze type. This is a way of saying x is between. Put two less than symbols. So these are, we like to squeeze numbers. We're always talking about, between such this and this. But how tall is that individual? Somewhere between, 5'9" and 6'1", somewhere in that ballpark. So x is between 2 and 10. So you take this as an interval. This is the note, by the way, it should be in quotes. This is just how you'd say it. But I would write it 2 to 10. So 2 comma 10 is the interval. Parenthesis on the 2, bracket on the 10. Equal to 10 is a possibility, but 2 is not included. The last one, not 7, means everything but 7. So this is everything but 7. So x can't be 7, it can be anything else. So if you can write an interval like this, this is a fun one. I can write negative infinity to 7, and then I don't include 7 because I can go right up to 7, right? Anything below 7 is good. I can do anything above 7. That's all good. But I can't do 7, and the way we do it with interval notation, to put a break, we do this union where both intervals are anything above and anything below 7, not including it. I think that this one is the most forgotten, most easily, but you can prove me wrong. I'd love to see that. That'd be cool. X not equal to 7, what we do is say anything to the left of 7, anything to the right of 7. Cool, yeah? I'm going to flip the page.